Recently is 1 million years ago. Modern computations of the age of the Earth indicate that it is at least 2,000 million years old, and probably a great deal older. About 500 million years ago, the rocks of the Cambrian period, so called because they were first studied in Wales, although they are widely distributed throughout the world, began to be laid down as marine deposits. These were such materials as pebbles, sands, and muds, which became consolidated to form, respectively, conglomerates, flaggy sandstones, and shales. The shales, which we can find in quarries today, contain the fossil remains of highly organised animal life, Brachiopoda and Trilobita, and this, of course, presupposes a very long evolution of living creatures in the days before the Cambrian period began. That is to say, in what is known as the Precambrian period, and indicates a very much earlier date for the origin of life upon the earth. The reason that fossils showing the evolution of Brachiopoda and Trilobita from much simpler forms of life are not known from the Precambrian rocks is that this early record has been destroyed by the great disruptive forces which were frequently at work on the rocks of Precambrian age, before Cambrian sediments were converted into hard rock. We pass over 1,999 million years from the first 2,000 million years, conservatively estimated as the age of the Earth, and so come down to a time just 1 million years ago. About the date, a marine deposit found in East Anglia had long been in process of formation. This material is called the coralline crag. At the time, in the latitude of Britain, the mean annual temperature was decidedly higher than it is now. Subsequently, increasingly colder conditions prevailed, and eventually the northern ice cap became so extensive that at its greatest development it covered this country as far south as a line we might draw roughly from Bristol to London. Before the ice finally disappeared from the surface of our islands, at the end of the glacial period, it alternately advanced and receded, so that 4 glaciations are now generally recognised. The period of cold conditions prevailing in northern Europe from the end of coralline crag times until the ice sheet finally receded fell within the geological epoch called the Pleistocene. If we use this term to indicate the Red Crag, Walton Crag, Newbourne Crag, Butley Crag, Norwich Crag, Weybourne Crag, Chilsford Beds and Cromer Forest Bed, as well as both glacial and interglacial deposits, with all contemporaneous materials. In the interglacial times the land surface was, of course, free from the activities of hunters and fishermen. In the absence of vegetation, immediately after glaciation, finely ground mineral particles left behind by the ice were very readily carried by wind, and this dust, coming to rest in the sheltered, less elevated areas of the land's surface, filled in the hollows, such as river valleys to a greater or lesser extent. This deposit is called loess, and it is found right across the Eurasian continent, from China to the British Isles. Subsequently, this wind-borne material was sometimes resorted by rivers and mixed with other sediments carried by the water.